Well, hi guys. So today we would like to just do a quick bar bending schedule. As I scroll down this page, you can just pause so that you can just read all the necessary literature. But what we need to do is do a quick practical of how a BBS is constructed, or bar bending schedule. The most important thing that you should know are the shape codes. The shape codes are the ones that help us construct a bar bending schedule. For example, with shape 12, 11, and the likes, and then the zero shape code is just a straight bar. Right. Now let's do a quick example. Something that will help us just get into the practical works. Apologies, my computer is very, very slow. Okay, this is a 6 meter long beam, which is simply supported on both sides. And as you can see on the section right here, it is 3y20, 4y20 is at the top and 3y20 is at the bottom, right? But how do we get to construct something like this, right? Given that we have a 6 meter length and our bars are 6 meter, like here in Zimbabwe, most of our bars just come in standard 6 meter lengths. Okay, so just a little bit of theory. Let's go to the whiteboard, right? As we have our beam, which is something like this. Apologies, my pen is not so good. We have maximum bending moment around here, and then here also towards this end we have a moment again. So these moments are hogging, these moments are, this moment is sagging, right? So how do we deal with this part? We need to have more steel here, more steel there, and then the bulk of some steel here and some here, some here. So the easiest way to construct a bar bending schedule for this is to use say a 6 meter length that is straight. Okay, let's draw, right? A straight 6 meter length. Okay, we need to draw. Okay, which is something like this, right? And then underneath this L bar we have a straight bar, right? I won't draw, right? But for this bar, right, it should have adequate anchorage length that goes straight into the what? Into the column. And then this bar just comes here, that's the anchorage, and then it goes again like this, and then we have a bar that goes straight like this. I don't know if it's clear to most, but this is what should be done. And then this red bar, which simply represent a length. So as you can see right now, we have one L bar with the second L bar, right? We are supposed to have about 4 L bars, but now for this one, the L bar that is on top, always the anchorage length gets into the column. That's what most designers prefer to do. But with some designers, they can just put the length as same as this L bar. And well, it depends on the detailing manual that you're using and so on. But personally, I prefer this top L bar to anchor deeply into the column, while this one, I just leaves a bit of a gap, right? This will be our column, right? This will be, and then the beam here goes on to be like this. So this is the way that I normally represent my rebar. This anchors deeply, while this comes onto that, right? So bear in mind that when we discussed, we say that there is a sagging moment right here. So these bars will just come as straight. So for this one, let's say this bar that's on the bottom that's written, it's actually bar mark 02, and this is bar mark what 01, which is top bar. For bar mark 01 and 02, now let's rename some of this. These 4Y20s, say they are also bar mark 02, right? I will explain why I say that, because I'm making some changes here. And then for the bars, for the L bars now, let's put them as what is 01. This is when we actually need to see the actual diagram for the bending moments and the shear force, because now with some programs they can just give you 4Y20 at the top and then 3Y20 at the bottom, but yet we don't actually know the actual bending moments and whatsoever. This is just a certain thing that someone sent me so that I can review and try to fix. But I had asked, I'd made a request for the actual the file with the bending moments and the shear forces, so I can review some of these beams. But well, in my experience, for a beam like this, since we have 6 meter beams, I would actually 6 meter length of we just make our top bars. So since we have L bars, this will be, say, Y16. Say we use for the bar mark 01s, which are the L bars, say 4Y16s top and maybe 3 at the bottom. So I'm just going to make the bar bending schedule for one side, right? Our beam is 300 by what? By 450, but 300 is okay. You can even make this about 2 meters. I don't have enough time to actually look up into the code and right. Say, all right, this is for a beam, because the member beam, right? So how many bars per member do we have? So for that beam, the beam we have for this L bars, we have 4 on top and then 3 on the bottom, right? Which is how many? 7. Remember, this is only for one side, right? And then the total cutting length is 2 meters plus 3, which is about what? 2.3, right? So I am not going to write the total number. So the total number is just 7. Remember, we're doing it for one side, then you can just mirror it since it's just the same. And then now for our 6 meters, remember we have how many? We have Y20, right? For our 6 meter straight bars, which is the bar mark 20. 6 meters in length, and then total number of this, we have 4 on top and at the bottom we have 7. So bars per member we have, okay, sorry. Wait, bars per member 7, but the total number of bars here, this is 2.3, right? Then 2.3 divided by 6 meters, so it should be 6 divided by 2.3. You do the math, that's the total number of bars that we have. Yeah, some write total number of bars in, but yeah, it all depends on the designer, but normally I use the total number of bars here. And then here, how many bars do I have? I have 7, which is just the same. and well, I'll forget all this. So my bar bending schedule is complete right now. And if there are any questions, well, feel free to just inbox me on LinkedIn or anyway. Thank you very much. So I'm going to end